All right, welcome back, Snow Leopards. This is your day one of cellular respiration. For your goal today, we're going to be developing a deeper understanding of how we get energy from food. By the end of the period, you should have your answers in your doodle sheet from A through H, and you also will have completed a worksheet titled, What Do We Know About Matter and Energy? All right, let's get started. Here you have a picture of a variety of organisms all eating food. Think about how often do these organisms eat? You've got people, so you should know that one. Horses. How often do horses eat? Do horses eat more often or less often than crabs, for example? Or turtles, which is what the crab is eating, the little baby turtle. What about parrotfish down at the bottom middle? It's about to take a hunk out of the coral. How often does a parrotfish eat? So we already know that we need to eat, but why do we need to eat? Well, we know that too, to obtain the matter and energy we need. So in our exploration of chemical reactions, we tracked matter and energy, and we kind of toggled back and forth between them. So before we continue on, we're just going to review separately what we know about each one. And of course, there will be connections between the two, and we'll acknowledge that as we go as well. All right, so you're going to be recording what you know about matter and what you know about energy. If you need to, refer to your doodle sheets from chemical reactions. So specifically, what do we know about matter from food? So how do we get matter from food? And what happens to all of the matter we take in as food? Another question, what do we know about how we get energy from food? So this is your do now. Get that worksheet titled, What Do We Know About Matter and Energy? And write down those model ideas from chemical reactions. So pause me now and write that down. All right. So how do we get energy from food? What's this connection? So we figured out that somehow we do get energy from food, right? And we know that that has to do with chemical reactions where matter gets rearranged. But how does that work exactly? I want you to go to your doodle box A and create some kind of a diagram about energy that represents the rearrangement of food in our bodies in doodle box A. So create some kind of diagram about how this works. Make sure you label your inputs and your outputs. So your inputs being the reactants or the food, your outputs being the product, and write anything that you know about them. So think about anything you learned from the previous model. Think about your carbs, your fats, your proteins, CHOM, whatever comes to mind with this. Think about that chemical reaction model. All right, so pause me now and fill out doodle box A. All right, well, the chemical reaction inside of us. So we know that we get energy from food through some kind of chemical reaction. And we know the reaction has different reactants and products. So the molecules are rearranged and the energy is released. But what are the reactants and products? What atoms are they made of? What do we know or wonder about the specific reaction in our bodies? All right, that's a reaction in my cat right there. So, yes, Winston. Here's your do now. So now I want you to write down the different reactants and products that might be in your body. Record your answers in doodle box B. So you're going to do this individually. So put me on pause, work individually, and write your answers in doodle box B. So think about what's in your body. What do you think the reactants are? And what do you think the product might be? Okay, so what are the reactants and what might be the product? Pause me now. All right. Hopefully you completed your list. Now talk it over with your group. After you share your ideas, record all of your ideas or record the ideas that you agree on in doodle box C. So pause me now and do that. All right. Now, moving on. Think about when you burned that Cheeto. Okay? Write down what you observed when the Cheeto burned in doodle box D. Then, I want you to consider the following questions. What happens to the matter, that Cheeto matter? What do you think the reactants and products are in burning food in this way? So what do you think the reactants and products are in burning food this way? You actually should know this one already. Does this match our earlier ideas about the reaction in our bodies? Explain that. And what is going on with energy? What evidence do you see of energy? Record your responses and then any other questions you have in doodle box D. So go ahead and fill that out completely and put me on pause. Okay, what makes something a fuel? So think about substances that burn once they've been lit on fire. List a few of those things in doodle box E. So put me on pause and do that. Sorry about Winston. He's hungry. Do we suspect they have anything in common? So does doodle box E have anything in common? Record your thoughts in doodle box E. So you can say that you have fuels. What do they have in common? And then you're going to continue on. You can talk with someone around you and share one of the ideas you came up with. All right, so what makes something a fuel? What do all of these substances have in common in terms of energy? What do they have in common in terms of matter? You're going to record that in doodle box E as well. So put that at the very bottom. What do the fuels have in common in terms of energy? What do fuels have in common in terms of matter? Put me on pause. All right, so what makes something a fuel? Here we have several different examples of fuels. You've got a paraffin wax candle. So again, look at the elements that make that up. You've got coal. Look at the elements that make that up. Wood, the elements that make that up. Heptane, which is gasoline, the elements that make that up. Methane, propane, all of these things. What makes something a fuel? Lots of carbon, hydrogen, and oxygen. Did you see a pattern there? Okay, so we've got carbon. So what else do these fuels need in order to burn or release their energy? What is the other reactant when something burns? So all of these things have lots of carbon, hydrogen, and oxygen. What else do they need besides that? And I think you already know. O2. So what else do we need to take in our body besides our fuel, which is food? What's that connection between how these things get burned and that produces energy? What do we need to take in our body besides our fuel or food? O2. We've got to be breathing in oxygen. So we're going to be looking at that much more in depthly and how that relates. O2 is definitely one of those reactants in our energy releasing reactions. So what exactly is burning? You've got your fuel. What other reactant do we need, again, besides the fuel? I'm sure you already know it. Put that in doodle box F. And following the conservation of matter, what are the likely products? So record in doodle F. Do you see any products when stuff burns? All right, so what exactly is burning? Well, if you take fuel, you add in oxygen, right? We have a release of energy, and we also have a transformation of matter. So then you've got a transformation into carbon dioxide and water, or water vapor. So again, to look at it, you've got to have some kind of a carbon fuel, some C, H, and O. You add oxygen. You have a release of energy, and that becomes carbon dioxide and water. Make sure you get this definition and equation in Doodle Box F. Okay, so record this definition for burning in Doodle Box F. Go ahead and put me on pause. All right, so what happens when we eat food? Well, you take in carbon fuel, some C's, some H's, some O's. You also take in oxygen, right? That causes a release in energy, and it transforms that matter into carbon dioxide and water. So how does our definition of fuel and burning fit our understanding of what might be happening with carbs, proteins, and fats in our body? Write down your ideas in Doodle Box G. What happens when we eat food? Put down your ideas. Put down any questions you might have. Pause me now. And again, sorry, make sure that you have some questions in there. If you do have questions, put them in there for now. Think about them for a second. All right, now you need to generate a question, a driving question for this unit. It's a short unit. We only have about 5 days, maybe 6 total, but so it's going to be quick. But what can be the driving question? I want you to think about what you were writing in letter G, box G. What happens when we eat food? How can you make that a more scientific question? So think about using that phrase, what happens when we eat food, to turning it into a more scientific question, asking about the cells in your body, and how it might be similar or different from burning, like burning fuel. Okay? So put down a driving question, talk about it among your group, and why don't you leave your notebooks open at the back for me to look at and see what your driving questions are. All right, that is day 1. Congratulations.